binomial expansion where the power n is a positive integer. Consider a plus b to the power of n. So it's a binomial because you have only two terms inside, and this is the unexpanded form. The expanded form is given by, so the first term is a to the power of n, the second term nc1, a to the power of n minus 1 b to the power 1, the third term nc2, a to the power of n minus 2 b to the power of 2. It goes on like this until the nth term ncr, a to the power of n minus r b to the power of r, which goes on up to the last term b to the power of n. So this is the nth term, the general term. So ncr, a to the power of n minus r b to the power of r, where r is less or equal to n. Now this is a finite series. It's a finite series. Finite series. Finite because the number of terms can be found. So the number of terms in this case is n plus 1, the power of n plus 1. It's a finite series. The difference between sequence is a set of ordered terms following some rule, t1, t2, t3. Then series is just the sum of the terms of this sequence, t1 plus t2 plus t3. Okay, now we shall consider the expansion of 2 upon x minus 3x to the power 5. So rearrangement, we bring the x on top, 2 to the power of x minus 1 minus 3x to the power 5. Further rearrangement, 2x to the power minus 1 plus minus 3x to the power 5. So this is the a, and that's the b. So the general term, tr plus 1, and cr, a to the power of n minus r, b to the power of r. So in this case, tr plus 1 is given by 5, because you have 5 as power, 5cr. The a actually is 2x to the power minus 1 raised to the power of 5 minus r, and the b is minus 3x raised to the power of r. Right, suppose you are required to find the coefficient. Find the coefficient of x to the power 1. So we go about it in tabular form. Okay, so that's a term. That term in x to the power of p. We split into two parts. We have the coefficient of x to the power of p. So the general term, tr plus 1. For the coefficient, we take only the values. So we take 5r, and then 2 to the power of 5 minus r, and then the 3, it's minus 3 in this case, minus 3 to the power of r. Now for the power of x here, x to the power of p, we take only the x component. So it's minus here, 5 minus r, and then x times x to the power of r. We combine these powers. So 5 minus 5 minus plus r again, plus 2r. Right, now you're required to find for x to the power 1. So the power for, so I just draw a line here. So for p equal to 1, so when p equal to the power, so we have minus 5 plus 2r equal to 1. So in this we have r equal to 3. R equal to 3. Minus 5 plus 2 are equal to 1. Negative 5 gives 5. 1 plus 5 equal to 6. Divide by 2 r equal to 3. Now we replace on this side, so r 3 plus 1, that's the fourth term. The fourth term will give us 5. We replace r by 3. 2 to the power of 5 minus 3, it's 2, and then minus 3 to the power of 3. Okay, so this part gives us 5 to the power 5c3 is equal to 10 times 2 to the power of is 4 times negative 3 to the power of 3 minus 27. This gives negative 1080. So that's the coefficient of x.